All right, welcome back. In this video, we're going to go over acid compound questions and pKa. A common exam question you would get on a midterm goes as follows. Given the compound below, which is the more acidic compound? Circle your answer. Another version of this question would be circle the most acidic proton in the compound. Basically asking the exact same thing. So to answer this, you have to go over some background knowledge. So here's the agenda. I want to give you some background knowledge about Ka and pKa. We're going to go over some tips and tricks as well as the pKa table. We're going to do some practice problems and challenge practice problems as well. Let's get started. I'm going to be honest with you. Actually, let me tell you a story first. I've taken an entire organic chemistry series, and every single professor I've ever had asked these type of questions. You'll see it for the rest of your life in organic chemistry. When students are given these type of questions, they usually guess. They guess because they don't actually know how to answer these type of questions. And they see that, okay, I have a 50-50 shot of getting this right, so they guess, and 50% of the time they're right. So professors got smart. Instead of asking one or two questions, they're going to ask you like 10 of these questions. Because they know that, okay, you're going to get half of them right if you guess. So my goal here is to combat that. And I want to teach you how to properly answer these questions without guessing. So, first, please watch my last video on Bronsted-Lowry mechanism. I promise I'm not view farming or anything. The reason is because what I'm going to go over in this video has to do with the Bronsted-Lowry mechanism and what they learned, what they basically found out, not learned. Knowing the Bronsted-Lowry stuff will make this stuff much more easy. So the link is in the description or in the comments if I remember. We'll see. So in the last video, I said acids like to give up protons to bases. But how likely is an acid going to give its proton to a base? In the Bronsted-Lowry mechanism, we just assumed the acid would just give its proton to the base, and that's how we did the mechanisms. But how likely? Well, there's a number, and that's called the Ka, or acid dissociation constant. It's a calculated number that tells us how willing a molecule will give one of its protons to a base. But here's the thing. We don't really care about that. That's all general chemistry crap. We don't care. But what we do care about is pKa. So why did I mention Ka? Well, pKa, the definition of pKa is the negative log of Ka. So when you're calculating, when you're given a Ka number, you take the negative log of that number and you get pKa. I'm almost certain you probably learned this in general chemistry and was completely lost. You're probably like, how the hell did they even get pKa? Where did this come from? Well, here's the answer. That's how they got it. By taking the negative log of the Ka, acid dissociation constant, they got pKa. But here's the thing, we don't care about that. We don't care about the equation. Right? This is not general chemistry, this is organic chemistry. So what do we care about? The only thing I want you to worry about here is this. Lower the pKa, stronger the acid. Know this for the rest of your organic chemistry career. This will help you. Lower the pKa, stronger the acid. A lot of people mistake this. They think, oh yeah, higher pKa, stronger acid. No. Lower the pKa, stronger the acid. You can also say the opposite. Higher pKa, stronger the base. All right. So here is a common table you'll probably see in a book. Even your professors may give this to you on an exam. It's a table of compounds and their respective pKa. So here's a compound here and their pKa next to it. Here's a compound with a pKa next to it. If your professor is nice, he or she will give you this table on an exam. If they do, you're home free. Easy A. at least for that section. If they're not nice and they don't give you the list, you kind of have to memorize it, unfortunately. If you memorize it, things will be good. You will get an A, most likely. Because a lot of students just don't want to memorize this. If you don't really feel like memorizing, there's another trick you can use. However, this trick is not reliable. It does not work all the time. It maybe works 80% of the time. And that is, remember, the more electronegative the molecule, the more acidic it is. Okay? This does not always work, and I'm going to tell you why in a second in the practice problems. We're going to go over a problem why this is not true. Tip number 3 is use the unspoken rule of 3 bonds. This is going to come basically come into play in the challenge problem. So don't worry about this now. We're going to go over it in the challenge problem. But this will help you a lot. So let's get started. Here are some problems. What is the most acidic compound, or what is the strongest acid? Rather, the strongest acidic proton, sorry. So here are the 2 molecules we're comparing, right? We're comparing this and this. What's the strongest acid? Well, I got these pKa values from the chart, right? So in pKa of 9.9 and pKa of 15.7. So just to prove to you, I'm not lying, 9.9 is this molecule right here, right? It's the same molecule. And here's water, 15.7. So I just got these numbers from the chart, right? This is the pKa column. I looked at the molecule, found the pKa value, and wrote it down. So 9.9 versus 15.7. Now, for water, always, please, if you're going to memorize one thing, just please memorize that water is 15.7. It's going to help you a lot in organic chemistry. So remember how I said the lower the pKa, stronger the acid? Well, 9.9 is smaller than 15.7. So that means that the smaller pKa wins. This is the stronger acid. Let's look at this one. If you have a pKa of 18 versus 15.7, I got these from the table as well, right? Just to prove to you I didn't lie. Right? 18 and water is 15.7 up here. 15.7 is lower than 18. So this is what the stronger acid. Water is the stronger acid here. Okay. Now, this was the problem I told you about. This is why electronegativity does not always work. If you look on the periodic table, nitrogen is more electronegative than carbon. Here's the handy-dandy table. Nitrogen is more to the right than carbon. That means it's more electronegative. But notice, you're like, wait a second, the pKa's are higher, right? The nitrogen pKa is higher. That shouldn't be. It should be lower. This is why I told you that electronegativity does not always work. And to explain this, I'm going to use an analogy. I'm going to warn you, this analogy is actually really stupid. And you're going to laugh. But it works because it helped me memorize it. Okay, imagine. Okay, Okay, imagine if I have a girlfriend. Okay, and we're in a really stable relationship. I'm single right now, but we're in a really stable relationship. Okay, so this is me, and this is my girlfriend here. Okay, stable relationship. We're triple bonded together. Like we're madly in love. Okay, and nothing can break us apart. Now we have that third wheel friend, right? That's always wants to butt in to all of our activities, and they're the friend is pretty nice, right? But it kind of gets annoying because they want to be included in all the activities that me and my girlfriend do, or my girlfriend and I rather. So we're like me and my girlfriend and I, sorry, are like we need to kick this guy out. Like I mean, he's a nice guy, but we need to kick him out of the group, right? Because we just want to be alone. That's what's happening here. Okay, we're like this molecule is like we need to kick this hydrogen out of here. We love being together, right? We're madly in love here. We just want this guy to leave, right? He's bothering us. That's what's happening. A triple bond is more acidic than a single bond. A stable relationship is more acidic, right, than an unstable relationship. Triple bonds are more stable. This also means that triple bonds are more acidic than double bonds, and double bonds are more acidic than single bonds. This is proven to you on the table here. Here we have a triple bond of 25 compared to a double bond of 44 and a single bond of 50. Now, here's that nitrogen in question, right? A pKa of 38, and the triple bond is 25. This is why electronegativity does not always work. A triple bond is more acidic, causes more acidity than a single bonded nitrogen. So this is why you have to kind of rely on the table. Always go off the table first. Then, if the table doesn't work, then use electronegativity. Here we have hydrochloric acid and hydronium, right? This is hydrochloric acid that's in your stomach, and this is hydronium. Chlorine is way electronegative than oxygen. So you should immediately, this is when you don't even have to look at the table, okay? This is chlorine and this is oxygen. More to the right equals more electronegative. You can immediately know that this is more acidic because it's more electronegative. Chlorine wants to keep its electrons to itself. Here you should know the answer because I already gave it to you. Triple bonds are more acidic than single bonds. Stable relationships are more acidic than unstable relationships. So this is the more acidic compound. I had this exact same one on my exam, by the way, like 2 years ago. Okay, this one. These pKa's are actually quite close. If you look at the table, -9 versus -7.3, right? So this is more acidic. But if we're to go off of electronegativity, notice that we have 4 oxygen atoms versus 1 oxygen atom. So this is more electronegative. If it's more electronegative, that means it's more acidic. All right, let's do the challenge problems. This is propranolol. Propranolol is what a medication is given to someone who has high blood pressure. It's a beta blocker. So if you're interested, you could actually watch my beta receptor video I made on physiology in the physiology playlist. So beta receptors, right? This is a beta receptor. This medication comes along and basically blocks it. So nothing can bind. Okay. What is the most acidic proton here? We have 2 in question, right? This one and this one. If you were given this problem, please do not write all the protons like this, all the hidden ones. They're not asking about that. What they're asking about is what's there, what's on the molecule that's listed. So the only thing that's listed is this and this. So what's the more acidic one? Well, here's how you solve it. This hydrogen is bonded to an oxygen. This hydrogen is bonded to a nitrogen. Which is more electronegative, oxygen or nitrogen? It's oxygen. Oxygen is more right than nitrogen, so it's more electronegative. Since it's more electronegative, this means that this proton is more acidic because it's bonded to the oxygen. Okay. This is L-DOPA. L-DOPA is a precursor to epinephrine, norepinephrine, and dopamine. Isn't that kind of interesting? That L-DOPA sounds like dopamine, right? So you could probably think, okay, we need this to make dopamine. But isn't it cool that it also makes epinephrine and norepinephrine? Cool how your body works. Rank the protons from highest to lowest in terms of acidity. So we have A, we have B, we have C, and we have D. Let's start with the lowest. Here, we have a hydrogen bonded to an oxygen, a hydrogen bonded to an oxygen, a hydrogen bonded to an oxygen, hydrogen bonded to a nitrogen. So these two are the same because they're both bonded to nitrogens equal spaced away. So they're the same thing. Well, exactly like last video, I mentioned, not last video, last slide, I mentioned that the oxygen is more electronegative compared to the bonded to the nitrogen. So oxygen is more electronegative. That means this is less acidic. Well, since nitrogen is less acidic than oxygen and the hydrogens are bonded to nitrogen, D is the least acidic. Okay. Now we get a little harder. How do we compare this, these, and that? Okay, first off, notice that these two molecules are exactly the same. They're identical. They're both bonded to benzene rings, and they're both bonded to oxygens, and they're equal distance away. They're the exact same thing. So their electronegativity is actually going to be the same. So it's basically a matter of what's more acidic, these or this? I'm going to tell you. This hydrogen is the most acidic. And the reason is that the unspoken rule of 3 bonds. What do I mean by this? Here's a little cheat you can do on exams. This will help you a lot. Sometimes protons are being influenced by more than one atom. Right? We have the oxygen here, but it could be being influenced by this oxygen here because it's in close proximity. And that is where the 3 bond rule comes into play. If a proton is within 3 bonds of another atom, that means it's significant. It actually plays a role in electronegativity. So let's take a look here. Let me use an orange. Let's do orange. Okay. We're going to count from this hydrogen, and we're basically play Monopoly here. We're going to hop. Every atom is a hop, is a space. 1, 2, 3. That's 3 hops. That means since it's in the 3 bond rule, this oxygen is playing a role in the acidity of this hydrogen. So is this oxygen because it is within 3 bonds. Now let's look at this one here. Let's do the same thing. 1, 2, 3, 4. 4 is higher than 3. It is too far away to play a role in electronegativity. Same could be said for this proton here. 1, 2, 3, 4. 4 is high. It's higher than 3. It breaks that 3 bond rule, right? It's too far away. So that means that this proton and this oxygen, this oxygen's not influenced as, sorry, I apologize. This oxygen is not playing any role in electronegativity or acidity for this proton. It's too far away. Same could be said for this hydrogen here. This oxygen is playing no role in acidity at all because it's too far away. However, this one is because it's close enough. It's 3 bonds away. It's close enough. So it's a matter of, since these are equal, it's basically saying 1 oxygen versus 2 oxygens. 2 oxygens is more electronegative than 1 oxygen. So B and C are identical in strength. Because remember, there's equals. They're exactly the same molecule. An OH here and OH here. They're on a benzene ring, and they're too far away, right? Look at this. Let's play a Monopoly game over here. Comparing this and nitrogen. 1, 2, 3, 4, 5, 6, 7. Way too far away. So they're identical. And that means A is the more acidic one. Oops, wrong color. A is more acidic because this proton's being influenced by two oxygens, one here and one here. This one here, because it's close enough, it's 3 bonds away. This one has no influence whatsoever because it's too far away, right? From here, we go 1, 2, 3, 4. It's too far away. Same for this one. 1, 2, 3, 4. It's too far away. And that's the answer. If you found this video helpful, please like and subscribe. And until next time, later.